Good morning all, my name is Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is image processing. Today I am discussing about question bank discussion on image restoration and filtering. So, image degradation. Here it is a model of image degradation and restoration process. The question is illustrate the different causes of image degradation. Image degradation is a process that acts on an input image f of x, y through a degradation function h and an additive noise nu of x, y. It results an degraded image g of x, y such that g of x, y equal to h of x, y into f of x, y plus nu of x, y. So, here image degradation and restoration process. So, degradation is nothing but we are going for the restoration of the process. So, f of x, y is going to be changing of f dash of x, y. So, here g of x, y is a degradation process, degraded output. It is a degradation process. So, when we have to converting into the degraded process, degraded output, degradation process is important. So, g of x, y equal to small h of x, y into f of x, y plus nu of x, y. So, nu is nothing but a noise. F of x, y is an input image. So, image degradation is a process that acts on an input image f of x, y through a degradation function h and an additive noise nu of x, y. So, the result in a degraded image g of x, y. So, g of x, y equal to h of x, y into f of x, y plus nu of x, y. So, the degraded output equal to degradation process with respect to the input. According additive noise is added to this term, where h of x, y is the spatial representation of degradation function. H of x, y is a degradation function. G of x, y is the degraded, and f of x, y is the input image. So, nu of x, y equal to noise. So, when we are going for the degraded output equal to degradation function with input function with noise. Okay, here it is a noise input function. So, what is a degradation function means? We are removing the noise. Okay, or it is a filter. It is a degraded output. Okay, noiseless output. So, where h of x, y is the spatial representation of the degradation function and the symbol is indicating convolution. We have only the degraded image g of x, y, and the objective of restoration is to be obtained an estimation of the original image and estimating the possibility on the original input image, and the general h and nu are closer to the f of x, y. So, here the image restoration is a process of recovering an image that has been degraded by some knowledge of degradation function h and the additive noise nu of x, y. The restoration degradation is modeled and its inverse process is applied to recover the original image. So, f of x, y is the input function. It is a degradation function. G of x, y restoration function. It is a output. Output image, input image, degradation function h, g of x, y, restoration filter. So, degradation and restoration. It is a noise is added to this one. So, up to this one, it is a degradation, it is a restoration. So image restoration and image degradation process. Degradation is nothing but a noise added, here noise removed, noise is removed. So demonstrate the model for image degradation. So we have to demonstrate, the question is demonstrate the model for image degradation. Degradation comes in many forms such as motion blurring, noise and camera misfocus. In cases like motion blurring, it is possible to come up with an very good estimation of the actual blurring function and undo the blurring to restore the original image. Okay, so degradation comes in many forms such as motion blurring, noise and camera misfocus. Okay, so we have to remove the motion blurring. How it is? So it is a degradation process to remove the blurring, degradation process to remove the noise, degradation process to smoothening or sharpening the edges. Okay, so degradation is a process to removing the noise. So it is a possibility to come up with very good estimation of the actual blurring function and undo the blur to restore the original image. So image restoration methods, various methods available for image restoration such as inverse filter, VNR filter, constraint least square filter, blind deconvolution method, etc. Some of the methods are either linear or nonlinear methods to remove noise and blurring, to removing the blurring. Okay, so restoration is there. F of x comma is a noise image. F dash x comma equal to noiseless image. Okay, it is the restored. So when f of x comma f dash is equal to replacing with this one, that is the restoration process. So various methods available for image restoration such as inverse filter, VNR filter, constraint least square filter, blind deconvolution method, etc. But some of the methods are either linear or non-linear to help remove noise and blurring of the images. Image restoration is the process of recovering the original image by removing noise and blurring of the image. It is difficult to avoid many situations like photography, remove motion blurring, and camera shaking, radar imaging, or remove the effect of image system response, etc. So, restoration is a process of recovering the original image by removing noise and blur from image, and it is difficult to avoid in many situations like photography, remove motion blurring caused by camera, and shaking of radar imaging to remove the effect of image system response, etc. So another question is explain the following filtering techniques, that is a noise model by mean of filter, constant models of mean of filter, homomorphic filter. So we have to explain these things. First we have to go for the explaining the filtering technique, that is a noise model. So what is noise model? Spatial noise is described by the statistical behavior of the gray level values in the noise component of the degraded image. Noise can be modeled as a random variable with a specific probability distribution function, PDF. Okay, so what is noise model? If noise model you know, then we have to apply the mask, then we have to apply the filter, and then remove noise. So noise models. Spatial noise is described by the statistical behavior of the gray level values in the noise component of the degraded image. Noise can be modeled as a random variable with a specific probability distribution function, PDF. What are the parameters for that one? Define the spatial characteristics of noise and whether the noise is correlated with the image. Frequency properties refer to the frequency content of noise in the Fourier sense. When the Fourier spectrum of noise is constant, the noise is usually called the white noise. Okay, then we have to go for the types of noises. So if noise is there, what are the parameters to finding out the noise? The spatial characteristics of noise is whether the noise is correlated with the image, and what are the frequency properties refers to the frequency content of noise in Fourier sense. Whether the Fourier spectrum of noise is constant, the noise usually is called the white noise. Okay, so what is a white noise means? Fourier spectrum of noise constant. That noise is called the white noise. Noise models. Noise tells unwanted information in digital images. Unwanted information in digital images. Noise produces undesirable effect such as artifact, unrealistic edges, unseen lines, corners, blurred objects, and disturbs background senses, etc. To reduce these undesirable effects, prior learning of noise models is essential for further processing. Okay, so noise models. Noise models are types of noises. Types of noises. It is the produce undesirable effect such as artifact, unrealistic edges, unseen lines, corners, blurred objects, and disturbs background scenes. To reduce these undesirable effects, prior learning of noise models is essential for further processing. So, what are the typical noise models are there? Uniform noise, Gaussian noise, salt and pepper noise, gamma noise, relic distribution noise. Okay, these are the types of noise. These are under noise models are there. So, how many typical noise are there? Uniform noise, Gaussian noise, salt and pepper noise, gamma noise, and relic distribution noise. So, important examples of noise models: Gaussian noise, relic noise, gamma noise, exponential noise, uniform noise, impulse, salt and pepper noise. So, Gaussian band rejected filter. These filters are mostly used when the location of noise component in the frequency domain is known. Sinusoidal noise can be easily removed by using these kinds of filters because it shows two impulses that are mirror images of each other about the origin of the frequency transform. So, Gaussian band reject filter. These filters mostly used when the location of noise components in the frequency domain is known. Sinusoidal noise can be easily removed by using these kinds of filters because it shows two impulses that are mirror images and other about the origins of the frequency transforms. So, what is a band reject filter? Ideal band reject filter, Butterworth band reject filter, Gaussian band reject filter. So, h of u comma v, if it equal to 1, d of u comma v, it is equal to 0, d naught, if it equal to 1, d of u comma v. So, w is the width of the band, capital H equal to u comma v is the 1 by 1 plus d of u comma v into w by d square. Gaussian band reject filter h of u comma v equal to 1 minus e power minus of something. So, from the left to right, perspective plots of ideal, Butterworth order 1 and Gaussian band reject filters are there. So, here figure A, figure B and figure C. What is happening from the left to right? It is the ideal filter, Butterworth filter and Gaussian. Gaussian band reject filter. So, input to output, what is happening here? The filter is there, but it is not looking good. So, as some blackish colors are there, it is not good. When we are going to this one, it is somewhat better, but what the Gaussian band reject filter is a final one when it is a order statistic one. So, there are depends on your noise level. We have to use the images. So, here these filters are mostly used when the location of noise component in the frequency domain is known, and sinusoidal noise can be easily removed by using these kinds of filters because it shows two impulses that are mirror images of each other about the origin of the frequency transform. And band reject filter is a h of u comma v. It is an ideal band reject filter. It is a w is the width of the band. Butterworth the band reject filter, h of u comma equal to 1 by 1 plus Gaussian band reject filter. It is a block diagram of ideal filter, Butterworth filter, Gaussian band reject filter. It is a band pass filter. Figure A, B, and C. Perspective of ideal filter. It is a Butterworth filter. Gaussian and notch filter. So, how to estimate the degradation function? Degradation comes in many forms such as motion blurring, noise, and camera misfocus. In cases like motion blurring, it is possible to come up with a very good estimation of the actual blurring function and undo the blurring to restore the original image. The mathematical model for image degradation, that is observed by image g of x comma y equal to f of x comma y into h of x comma y plus e of x comma y. It is a degraded output input. So degraded output equal to input function with the degradation process according with the noise levels. Okay, so degradation comes in many forms such as motion blurring, noise, and camera moves focus. In cases like motion blurring, it is possible to come up with very good estimation of the actual blurring function and undo the blurring of the original image. So the mathematical model for image degradation is the observed of image g of x equal to f of x comma y into h of x comma y plus e of x comma y, where star denotes the convolution function. It is nothing but a convolution function. So when we are going for the degradation process, degradation function, it is nothing but a, we are going for the noise image converted to the noise level, noiseless image. This noise level process I am calling as a degraded output degradation function or degradation process. So f of x comma is a noiseless image, h of x comma is a degradation function, and e of x comma is a noise function. So f of x comma y. So noiseless degradation function and the noisy of the each pixel value. So here one example of input is the original image, degraded function h, it is a g of m comma 1, noise is added. So it is a degradation function. It is a restoration process. So degradation process, noise is removed. Here restoration process means restore with original image. So f of m comma n is an input function, degradation function, output is g of m comma n, noise is added to this one. Okay, noise levels are there. After this one, g of m comma n is a degraded output, restoration filter, and output is a restoration filter. Okay, these are the references up there. So in this example, majorly we discussed illustrate the different causes of image degradation process. So image degradation is a process that acts as on an input image f of x comma y through a degradation function h and an additive noise nu. So g of x comma equal to h of x comma y into f of x comma y plus nu of x comma y. So it is the image degradation. Here h of x comma is a spatial representation of the degradation function, and the degraded output is a g of x comma y. The objective of restoration is to obtain an estimating of the original image. So this estimation is possible to the original input image, and more likely h and n are close to the f of x comma y. So here it is a degradation function. it is a restoration function. Here a degradation function means here noise is added to the input. Here it is a output is a noiseless output. Okay, so f of x comma y equal to f dash of x comma y. So demonstrate, one question is there, demonstrate the model for image degradation. So how we are demonstrating the model of the image. So degradation comes in many forms such as motion blurring, noise and camera misfocus. In cases like motion blurring, it is possible to come up with very good estimation of the actual blurring function and undo the blurring to restore the original image. And image restoration method is that various methods are available for image restoration such as inverse filter, Wiener filter, constant least square filter, blind deconvolution method, etc. Some of the methods are linear and non-linear methods to remove noise and blurring the image. So image restoration is to remove the blurring, but how the blurrings are came due to the camera shaking or misfocus of the camera on the object. Another question is explain the following filtering techniques, that is a noise model and a model of mean filter and homomorphic filter. So first one is a noise model. So noise model is a spatial noise. It is described by the statistical behavior of the gray level values in the noise component of the degraded image. Noise can be modeled as a random variable with a specific probability distribution function PDF. What are the parameters is that spatial characteristics of noise and whether the noise is correlated with the image. Frequency properties are nothing but a frequency content of noise in Fourier sense. The Fourier spectrum of noise constant, the noise usually is called as a white noise. So white noise of slices, one type is white noise. In the noise, when the noise is constant, that is a white noise. In the noise models, it is unwanted information is there in the digital images, and it is produces undesirable effect of artifact, unrealistic edges, unseen lines, corners, blurring images, all are. So these are all under noise level. These are all under noise levels. So we have to reduce this noise. Reduce these undesirable effects. Prior learning of noise model is essential. So finding out the level of noise. So what are the typical noise means? Uniform noise, Gaussian noise, salt and pepper noise, gamma noise, relic distribution noise. Another important examples are there: Gaussian, relic, gamma, exponential, uniform, impulse. That is, impulse means salt and pepper noise. So Gaussian band reject means these filters are mostly used when the location of noise component in the frequency domain is known. Sinusoidal noise can be easily removed from using these kinds of filters because it shows the two impulses that are mirror image of each other about the origin of frequency transform. And in the band reject filter, ideal band reject filter is one, Butterworth band reject is second one, Gaussian band reject is a third one. So h of u comma v equal to 1, 0, 1, d of u comma v, d naught minus w by 2, d of u comma v. W is the width of the band. Butterworth band reject filter is h of u comma v. Gaussian band reject filter is capital H of u comma equal to 1 minus e power minus t square. It is one example of left to right. It is an ideal filter. It is a Butterworth filter. It is a Gaussian band reject filter. So every comparison, they are somewhat better with the original one. It is a noise levels. So in the noise levels, it depends on noise levels, types of filters we need. Types of filters we have to use. Another, it is a band pass filter. So in the perspective of ideal, it is an ideal Butterworth filter, and it is an ideal filter, Butterworth filter, Gaussian and notch filter. So how to estimate the degradation function? Degradation comes in many forms such as motion blurring, noise and camera misfocus. Okay, motion blurring is the major problem of this one. So we have to use degradation process to reduce the blurring of the image. G of x comma equal to f of x comma y into h of x comma plus e of x comma y. Here f of x comma is a noiseless image, h of x comma is a degradation function, e of x comma is a noise level of the each pixel band. Okay. In the figure A, it is a degradation process. Original image, degradation function h, noise is new, output is g of m comma 1. It is a degraded output. This degraded output is a degraded input for this one. It is a degraded input for the restoration. It is a restoration filter. It is a f dash of x, f dash of x comma y. So finally, f dash of x comma y equal to f of x comma y. So these are the references of this one. So finally, we discussed periodic noise, Gaussian band reject filter, and types of noise or noise models. These are the noise models, and what are the parameters, and these are the noise models in the filters. Okay, so it is a restoration method. It is a degradation. It is a degradation process, restoration process. In the restoration, linear and non-linear, two types are there. In image restoration. Okay, these are about the image degradation and restoration process. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.